Okay, let's dive into this. Welcome to the Explainer. Today we're unpacking a massive structural paradigm shift in utility-scale battery energy storage systems, or BESS deployment. Look, if you're involved in energy infrastructure, you know that understanding what actually gets a project built on time is literally everything. But here's the wild part we're going to uncover today. The industry as a whole, we've been looking in the completely wrong direction.
For years, it seems like everyone has been totally fixated on metrics like battery cell availability indices, container costs, lithium supplies, you name it. But the real story, the true critical path for deployment, has shifted entirely over to substation hardware. Basically, if you are a developer and you're only focusing your risk assessment on the batteries themselves, you're entirely missing the massive roadblocks sitting dead ahead of you.
And just to show you exactly how severe that roadblock has become, take a look at this. 36 to 48. That number is the massive stretch in major OEM lead times in months for this critical hardware. Just think about that for a second. We're talking 3 to 4 whole years just waiting for equipment to show up on site. It's completely derailing standard project timelines and honestly throwing multi-million-dollar schedules into absolute chaos.
So here's our roadmap for today's Explainer. We're going to start with the wrong obsession, then we'll uncover the true critical path. After that, we'll break down the anatomy of the delay, explore what we call the shovel-ready trap, and finally wrap up with some strategic procurement frameworks.
All right, part 1, the wrong obsession. Misplaced priorities in BSCS. Right now, development teams are just obsessing over battery cell availability indices. They're scrutinizing container costs down to the absolute penny and rushing to secure that initial battery supply. And hey, locking down batteries feels highly productive, right? It feels like real momentum. But the truth is, this is an illusion of progress. It heavily distracts us from the actual, physical threat to getting these projects energized.
Which brings us to Section 2, the true critical path, the real project killers.
It turns out, step-up transformers and high-voltage switchgear are the true bottlenecks here. I mean, think about it. Securing a grid connection point or having a massive warehouse literally stuffed full of battery cells is entirely pointless if your crucial substation hardware won't arrive until the end of the decade. This hardware is the physical bridge that connects your batteries to the grid. It's honestly like buying a multi-million-dollar mansion, but having to wait 4 years just to get the key to the front door. Without it, your project is fundamentally paralyzed.
Let's move on to Section 3, Anatomy of the Delay, Structural Supply Chain Constraints.
Now, what's really interesting about this slide is that a massive chunk of this delay comes down to one thing, GOES, or grain-oriented electrical steel. Now, this isn't just your run-of-the-mill steel. It's a highly specialized, precision-engineered material that is strictly required to manufacture the custom high-voltage windings for these transformers. And right now, it's facing critical global shortages. This incredibly niche material has unexpectedly become the ultimate project killer. Simply put, if manufacturers can't source GOES, the transformers just cannot be built, period.
So, why exactly is there such a massive shortage? Well, we are dealing with a perfect storm of macroeconomic drivers. First, there's a huge global surge in data center loads, obviously largely driven by the AI boom. Then you've got massive grid modernization efforts happening all over the place, coupled with an absolutely unprecedented level of renewable integration. The takeaway here, you aren't just competing with other storage projects anymore. You are forced to compete with massive tech giants and national grid operators for the exact same manufacturing capacity in those exact same custom windings.
Next up is Section 4, the shovel-ready trap, the cost of ignoring balance of plant.
The reality on the ground right now is pretty stark. Developers who treat balance of plant items as just an afterthought are finding themselves sitting on permitted, shovel-ready sites with zero path to energization. And you know, having a permitted site used to be the gold standard in this industry. It meant you were totally ready to go. Today, it means absolutely nothing if your timeline has been completely rewritten by balance of plant constraints. Your site might be shovel-ready, but your actual energization date is years away.
Because of this exact dynamic, 2027 completion targets are now at severe risk. We aren't talking about abstract theoretical problems a decade from now. We are talking about your near-term pipeline and your immediate financial commitments. Missing these energization dates often means losing out on vital tax credits or even defaulting on strict power purchase agreement commitments. Make no mistake, this specific manufacturing backlog is the absolute primary threat to hitting those crucial targets over the next couple of years. Okay, let's move to our final section and see how this all builds into solutions. Section 5, Strategic Procurement Frameworks and Protecting Project Timelines.
Here are the 3 essential strategic procurement frameworks that you have to adopt immediately if you want to save your project schedules. Step 1. You must pivot your organizational focus away from just cell availability and put it squarely onto substation hardware. Step 2. Lock down those transformer manufacturing slots years in advance, and I mean years, not quarters. Step 3. Integrate balance of plant constraints directly into your initial lifecycle planning. This can no longer be an afterthought. It has to be the foundational timeline of your entire project from day one.
So, I want to leave you with this final provocative question. For all the EPC directors, project developers, and asset strategists out there listening, how early in your project lifecycle are you actually locking down transformer slots? Are you actively adapting to this new critical path? Or are long lead balance of plant constraints already rewriting your construction timelines without you even realizing it? Guys, it is time to urgently rethink these supply chain vulnerabilities. Thank you so much for joining me on this explainer. I really hope this gives you the exact clarity you need to keep your projects on track.